Good morning to one and all present here. On behalf of Jaggu Singh's Charitable Trust, Thakur College of Science, I, Pradnya Sawal, Coordinator of BSc Computer Science, welcome everyone for the webinar on Big Data Analytics, organized by the Department of BSc Computer Science and BSc Information Technology. This webinar is about what is big data, how it has been progressed over years, what are the characteristics and objectives to use it, as well as the 3 V's. Also, the webinar is going to discuss about the implementation, trends, and the industry standards. Today, we have with us Dr. Sheetal Rathi, who is presently working as Professor and Head of Post-Graduation in Computer Engineering Department of Thakur College of Engineering and Technology. She is a computer engineering graduate in the year 2000 from Amravati University and completed her PhD in the area of data mining and high performance computing in the year 2016. She has a rich working experience of more than 18 years and has been working in TCT from last 14 years. Dr. Sheetal Rathi has a passion for teaching and joined TCET in 2007 and went on to contribute immensely to the growth of the department. In a journey of 14 years in the institute, she has been taking various roles and responsibilities like project coordinator, PG coordinator, deputy HOD, and BOS chairman of Computer Engineering Department. In the capacity of the head of the department, she has been a key member in various committees at the institute level and has faced various committees like NBA, NAT, Autonomy, and has drafted syllabus for CDCGSH, Autonomy scheme, and BTech in AI and DS, which got approval with 60 intake from the academic year 2020. She has taken training for NBA in sister concerns of TCET and was panelist in IEEE conference. Apart from this, she has a keen interest in taking various quality initiatives in education and is certified ISO auditor and was certified RBNQ examiner in 2016. Her research area includes data science and high performance computing and is currently guiding 5 PhD research scholars in the area. She has delivered talks on data science and high performance computing at other institutes as well. She has received grants from UOM and AICTE. She has more than 50 publications in various peer-reviewed journals and international conferences. She is also a reviewer for IEEE and Springer publications and TAC committee member for PhD at NMIMS. We are thankful towards Dr. Sheetal Rathi ma'am to accept our invitation and sparing her valuable time. Before starting with the webinar, I would like to call upon Dr. Millie Desham, IC Principal of Thakur College of Science, to motivate the students with her valuable words. Millie ma'am.
Thank you, Pradnya. A very good morning to one and all present here. Pradnya, I hope I'm audible.
You're audible.
Right. A very good morning to one and all present here. Respected today's speaker, Dr. Sheetal Rathi Madam, Coordinator of IT Department, Ms. Aishwarya Madam, Coordinator for CS Department, Pradnya Ma'am, Ms. Tahira, Assistant Professor from ITCS Department, other faculty members, and my dear students. We are very much pleased to conduct this webinar for our students and faculty members on big data analytics. We have chosen this topic as this is the need of the hour, you can say, which each and every student of IT or computer sector must be aware about. On behalf of ZSCTs, Thakur College of Science, I once again welcome all the faculty members and students for the webinar. Also, a big thank you, Dr. Sheetal Rathi Madam, for accepting our invitation. And I'm very sure, along with me, all are eagerly waiting to hear from such a renowned and experienced speaker. Now, without wasting much time, I would request Pradnya ma'am to continue with the webinar. Over to you, Pradnya. Thank you so much.
Thank you, ma'am, for your kind words. So as the webinar is live on YouTube, please do like, share, and subscribe to our channel. Now, with no further delay, I would like to hand over the session to Dr. Sheetal Rathi ma'am for starting the webinar. Over to you, ma'am.
Thank you, Pradnya, for such an exhaustive introduction. Yes, good morning, everyone, my dear students, all the faculty members. So, Pradnya, you'll allow me to share the screen?
Yeah, ma'am. Just a second. Ma'am, you can share it now.
Yeah. Just give me a second. Pradnya, I think some settings are disabled. I'm not able to share the screen.
Ma'am, just a second, no?
Is it visible?
Yes, ma'am, it's visible.
Okay. So, good morning once again, everyone. Today, as Pradnya rightly mentioned, I'll be delivering a webinar on big data analytics, just some glimpses of this emerging field. Why is it so much required? Some history about this, and along with the history, some predictions also about big data analytics in future. So if you see this ongoing pandemic, it has changed the experience forever, be it for an employee, for a citizen, for a customer, for a student. Everything has changed since pandemic. While the unrelenting pandemic, it continues to still roll on, the future is not going to be the same. We all know that. There have been a lot of changes in the last few months in specifically consumer preference and subsequently the way the businesses are functioning. If you see the businesses, they are witnessing altered consumer buying pattern, making them rethink how they can deliver relevant customer experience to support the continuity and in their business, right? So as a result, one of the most significant changes which have been is nothing but your digital acceleration. Now, for the push towards a digital future, data science and data analytics, they are going to play a very crucial role. That's why it is rightly said that data is the new oil. Now, when I say about oil, you know it is very expensive, it is very precious. So you have to diligently use it, right? I'm sure you all agree that in this pandemic, the only thing that was running uninterrupted, catering to the needs of people, was nothing but your internet. And when I'm talking about internet, imagine the kind of digital data which is being generated every minute, right? Right now I'm giving the webinar, a digital content is being generated. So imagine with every minute the kind of digital data which is being generated, be it your online shopping, maybe for your day-to-day essentials, your online education, the digi payments which you are doing, right? Then maybe increasing use of fastags on the tolls, engaging yourself through social media for that matter, right? So everything, whatever you are using nowadays, specifically in pandemic, is mostly creating enormous amount of digital data. Now, let's take the specific scenario of businesses, for example. The lockdown and other restrictions that have come along with this COVID pandemic, it has left the businesses struggling to operate and carry your day-to-day operations in a very smooth way, right? So maybe with decisions such as layoffs, you see the newspaper, you read the newspapers every day. So decisions such as layoffs, salary cuts, or maybe even frozen hiring, they are not hiring anymore. The companies are struggling to make the ends meet. While they are finding themselves in a lurch nowadays, one thing that we are continually hearing is that the digital is the future. Moreover, if you see now with remote working on the rise, the business leaders, they are adopting digital tools and data science models to optimize the business processes, regulate the spends which they are doing, measure their return on interest, investment, sorry, then gauge the long-term business impact and much more. The companies are even looking to accelerate the investments in technology such as artificial intelligence, then virtual reality, cyber security to bring about the required transformation in the businesses. Specifically, I would say the adaptation in the tech companies, it is done so smoothly that many big companies, they are now thinking of adopting the work from home culture for its employees even after the pandemic is over, because they are saving a huge amount of cost on the kind of rentals they are paying for the offices, right? So specifically for tech companies, this model will still continue. In education center also, I would like to say that education sector also slowly and steadily, it is going to focus more on blended learning kind of thing, wherein some part will be online and some part may be offline mode also, because in education also it is working very well, the online mode. So if you see, the gist is the data science and analytics, it is now the key drive to make a smooth transition even after the post-COVID world. So with this brief introduction on big data analytics, let's see, have a look basically at what the world's leading research and advisory company Gartner, it has predicted about data analytics for the next decade, that is from 2020 to 2030. So just a glimpse of few of the predictions I'll be reading. So by 2020, we are already in 2021, augmented analytics will be the dominant driver of new purchases of business intelligence, analytics and data science and machine learning platforms and of embedded analytics. By 2020, AI will become a positive net job motivator, creating almost 2.3 million jobs while only eliminating 1.8 million jobs, because everywhere you hear, because of digitization, because of automations, there will be less number of jobs in the market. But specifically in this particular domain, there will be an increase of almost 2.3 million jobs, right? More than 50% of new business platforms will use continuous intelligence in their system by 2020. By 2022, 90% of corporate strategies will explicitly mention information as a critical enterprise asset and analytics as an essential competency in their company. The global augmented analytics market is expected to grow from USD 4.8 billion in 2018 to almost as good as 18.4 billion by 2023 alone, at a compound annual growth rate of 30.6%. And the global AI analytics economy will increase from about $1.2 trillion last year to about almost $3.9 trillion by 2022, while McKinsey sees it delivering global economic activity of almost around $13 trillion by 2023. Now, if you see at these staggering figures and enormous amount of predictions which have been done by Gartner itself, I'm sure you all will agree that data analytics, data science, artificial intelligence, this will be nothing but the future in the next decade. If you have heard about the paradigm ABCD in computer science, A stands for artificial intelligence, B is your blockchain, C is your cloud computing, and D is your data analytics. So these ABCD paradigm is nothing but it is going to be the future in the next decade. Okay, a very interesting linkage, I would say, right from the evolution of your data to your what we call it as wisdom or value in your data science or data analytics field. So how it slowly progresses right from your raw data to information, to knowledge, to insight, and then finally becoming wisdom, wherein we take real-time decisions and apply it in your real-time world. So one of my very good, favorite examples, which I generally quote for this particular slide, and as just to relate it better, I'll just take the example of this pandemic situation itself. With this situation, I'll just take you through a journey of how data has evolved into information. From information, it has progressed to knowledge. From knowledge, we gain insights, and from insights, we are in a position to take a particular decisions or make wisdom. Okay. So if you see here, data is nothing but maybe in a particular area, a geographical location, you do a COVID testing, and between the various people of that particular area, and from that is nothing but your data. And from your data, you try to find out what are the positive, who are positively tested and who are negatively tested, right? So that becomes your information. Now, assuming the green circles in this particular block are nothing but people who are being tested positively, okay? And purple are nothing but the people who are being tested negative, COVID positive and COVID negative. Now, after this is done, after you know the information that who are the positively tested people and who are the negatively tested people, you try to find some correlation between the patients by doing some contact tracing, right? You have heard about all these buzzwords in the newspaper nowadays, all thanks to the COVID. So you try to establish some contact tracing between these positively tested people. So basically, you try to join the dots of all the greens and try to see whether they are from the same family, whether they are from the same community, and something like that. Once this is done, once the contact tracing is done, then you try to find some insight from this knowledge. Now, when I talk about insight, insight is nothing but maybe some diagnostic kind of thing, that what led to the positivity of these particular people, as in the source from where they could have got the infection. Maybe have they attended some common wedding or a common function, or maybe is the workplace same? Are they going to the same educational institute? Are they traveling by some common mode of transport? Maybe nowadays locals have started, but otherwise also if you're doing a carpool or you're traveling by bus. So is there a way where you can establish or try to find insight key all the positive people or some of the positive people? Were they in a common forum? Were they traveling with a common mode of transport? And something like that. From that, you gain the insights, right? Now, when you gain the insight, the power to take the right decision, that is a decision-making capability, will nothing be but adding the value addition to your insight. Because although you have found some insight, let us say you have found the insight that a particular zone or maybe a particular geographical location is more contaminated as compared to the other geographical locations. So if you stop there only, then it is not making sense, right? You have to take some action based on the insight which you have gained. So the action may be, in this case, you declare that as a containment zone and try to restrict the movement in that particular area and so on, right? So if you see this last block, which is nothing but wisdom. So after establishing contact tracing and all the positives in that particular area, what you do is you declare it as a containment zone and restrict the movements and whatsoever, additional restrictions you are going to do in that particular area. That is nothing but the wisdom or the decision making which you are taking. So right from your raw data, how it has progressed to your information, from information to knowledge, knowledge to insight, and insight to wisdom. This entire information continuum, if you see, is nothing but the life cycle of a data scientist or a data science process, I must say, to be precise. And somewhere in between lies your data analytics. So in short, I will say that data analytics is nothing but it comes under the umbrella of data science. And it is the heart of the entire data science process. So in nutshell, just a basic definition of what is big data. So big data is nothing but it is a buzzword or a catchphrase, which is used to describe a massive amount of both unstructured as well as structured data that is so large that it's difficult to process it using your traditional database or RDBMS and the basic existing software techniques. And in most enterprise scenarios, the data is too big or it moves so fast, which we call as streaming data, that it exceeds the current processing capacity of your rudimentary RDBMS techniques. So let's see some characteristics of big data, which we call, I mean, how do we differentiate whether it is a normal data or it is a big data? So the first characteristic of big data is the mining, the storage of the data, the analysis, sharing, and of course, visualization of that particular data, the graphical, you can say the graphical visualization or picturization of a data in a particular format. If it can be done specifically, then it is called a big data. It is also a massive amount of data that is quickly growing. I'll show you some figures, the rate at which the data is being growing with some basic examples, which every one of you as a student also, you must be using in your day-to-day life. So we'll see some examples later on the amount of data which is being consumed and which is being generated. The third characteristic, which I would like to focus on big data, is that the data that grows so quickly in volume that it can't be processed with your conventional means. That is your typical traditional RDBMS, because the data is growing at an exponential rate, all thanks to the digitization and the modern means and the low cost in the hardware, so that the data which is being generated is also able to be processed at a very fast speed. Coming back to the progression of data analytics, over the last 3 decades, if I would say, right from the 1990s to your 2000s and now 2015 onwards, I would not deny that data was not there in 1990s also. Of course, it was there. But over the 3 decades, the way in which it has progressed is very impressive, if you see. So, to start with, in 1990s, if you see the data which was there, it was mainly IT generated business intelligence data. By IT generated business intelligence data, I mean the analytics which was done on that particular data. It was mostly coding based analytics, and it was basically descriptive in nature. And since it was coding based, it was only available to the IT users of that particular company. And it was done manually that time. So it almost took months to generate some insights from that particular data. I already told you the continuum of data from data to insight or wisdom. So imagine in 1990s, the time which it took to generate insights from the data was almost going in months, because it was mostly done manually by the IT professionals. Then gradually in the next decade, that is, if you see in 2000s, specifically in the early 2000s, came the business generated business intelligence. Now the difference here was the analytics was done using some advanced tools and visual based dashboards. So it was mostly diagnostic in nature, and mostly it included your self-service data exploration, since it was business generated. A major change here from your 1990s was that now the data was available to the business users also, as well as the IT professionals. And now it took only few days to generate insights out of the particular data. Rather than taking months to generate insights, now it took some days to generate the insights from that particular data. From 2015, if you see, came the era of your machine learning, and the data generated here was nothing but your machine generated business intelligence data. The analytics are mostly augmented, AI augmented analytics now. That is, they are auto generated with the help of your high end AI tools. The data which is generated is mostly predictive as well as prescriptive in nature. Basically, they are telling you about the possible future trends, and it is available to any user, and the insights are almost real time now. So if you see the gradual transition now, right from 1990s, where it took months to generate insights, in 2000 it took some days to generate insights. Now since 2015, and specifically now in after maybe you can say 2019, specifically the because of augmented analytics, the data which you are dealing with and the data which is being processed is almost in real time processing, which you can see. I'll give you a very simple example of your real time processing of your data. All of y'all have used Ola, Uber at some point, right? You have used your GPS tools. Now, when you are using your GPS tool or Google Maps, you can see the real-time traffic or the real-time best route possible to travel from one place to another place in shortest time, right? So that is nothing but an example of real-time data and how it is processed, and it is giving you insights basically in real time. Okay. So another example of your machine generated BI, if you see the analytics, if you have done, I don't know how many of you all have checked Google Analytics. Whenever you surf, no, Google has this option of Google Analytics. If you have created a website of your own, basically, so using Google Analytics, you can check the web traffic of your particular website, your return of investment on the advertisements which are going on your website, and so on. So yeah, the analytics, as I told you, it is available to the layman or the end user also now, as compared to only IT professionals or business related business professionals. Now the analytics which is available is for the end user as well. So slowly we have seen the progression of data analytics over the 3 decades. Okay, so this is nothing but a very comprehensive slide of how your big data has progressed from I mean, what are the various layers of big data, and what are the basic objectives of big data? So if you see the bottom of this slide, this is nothing but the all kind of data which you deal with nowadays, be it your web data or your social media data, be your city data. Now by your city data, I mean, you are talking about smart cities, right? Your IoT, Internet of Things, devices connected to each other. So that is nothing but your city data. Then you have your financial data, then logistics data, specifically in your manufacturing company, when where you maintain the logistic data. Then of course the agricultural data, which is again one of the upcoming fields where your data analytics is being used, the smart agriculture area. And your sensor data, or maybe your satellite data, your surveillance data. These are the various sources from which the data is coming, right? And if you see the various sources from which the data is coming, there are various types of data which is coming. It can be textual data, it can be structured data, then machine generated data, image data, video data, all kind of data which is coming. So you extract the data, that is you do data extraction. You integrate the data with your existing system. You do the pre-processing, you filter out the anomalies in the data, and you make it ready for processing. Okay. So that is nothing but data integration. After the data integration is done, then you see the big data computing and the data management part, followed by your data mining and visualization part. Specifically to visualization, when it comes to visualization, is nothing but whatever insight you have gained through your analytics, no? That insight, how you represent or show that insight to your end user or the end customer. Because if you see, your end customer in this case is nothing but maybe online shopping, smart cities, the healthcare sector, the finance and risk management sector, the farming sector, as I told you. So all these are the end users who are going to use the insights which you have generated using the entire process. So, but it is not necessary that the end users will be tech savvy in that case, right? They will be computer literated. So you should have ways and means to present or convince your insights to these end users so that they buy your products, right? So that is where your visualization plays a very important role. And of course, along the entire cycle comes your various policies, be it government-related policies, be your business-related policies, and so on. And with that comes your privacy and security as well. This is nothing but, if you see, it is not the entire process of analytics, that is the data value chain of BI and analytics, to be very specific. So right from the various sources from which you can get your data, once you get the data, as I mentioned in the previous slide, there can be n number of sources from where the data can be generated. You may not even think of it, but you are one of the data generators. For example, if on a shopping website, let's say you are simply surfing the Amazon website and you go or surf through some of the products. Now, some of the products you put in the cart, but some of the products you simply surf and go through and just do a basic comparison, and you don't put it in the cart. But still, the small things as hovering of the mouse on a particular product, even that data is being captured by the backend of that particular website. That I'm again repeating, I'm not clicking on a particular product, I'm not putting it in the shopping cart, I'm simply reviewing that particular product and hovering my mouse for some time on a particular product as compared to the other products. So that type of data is also being captured by the backend for a better customer experience, that maybe in future you may be interested in buying a similar kind of products or a competitive product of that particular nature. So that is nothing but getting the data. So in this case, you indirectly are contributing to generation of the data also. So you get the data. Second is you connect to the various data sources. Now the sources from which a data is you are collecting can be enormous. Let's take the same example of Amazon for that case. You as an end user, based on the surfing of the website, you are generating data, so that can be a data source. Then someone may be putting some reviews on social media site about that particular website, or maybe some ongoing sale on the website, or maybe some specific product on the website. So the reviews on the websites are nothing but a different data source. Again, maybe your banking transactions, so the kind of transactions which you are doing, the payment transactions for that particular company, can another be medium for data source. So all in all, there will be, for a particular website specifically, I'm saying, there can be n different sources of data which they are supposed to collect and analyze. So you connect to all the data sources globally. Okay, that is at different geographical locations. Once that is done, then you prepare your data. That is the third important step. And if you see the first, second, and third step, that is the data preparation. These three steps together, they almost consume more than 75% of the time in the entire cycle of the data analytics. So imagine the kind of time which is being taken or consumed using only for the pre-processing of the data, because, and it is given due weightage also, because if the pre-processing of the data is not done well, then the input to your entire cycle is only wrong or not very accurate. And if the input is wrong, however how much good analysis you do, you find insights, you visualize everything, but if the input is only wrong or maybe not very accurate or precise, there are high chances that the output is also not very impressive, right? And that is why majority of the time is given to this data pre-processing and preparation of the data. Once the data preparation is done, then you perform the analysis on that particular data using various inbuilt analytics tools. After doing analysis, you find some insights or knowledge from those analysis. Once you gain some insights, you visualize the findings or the insights which you have got, and then after visualizing the findings, you present the findings to the end user, to the company, to the business partners, and so on. Once the findings are presented, then you distribute the information to the end user, right? So this is nothing but the entire value chain of your business intelligence and analytics. In short, I would like to say that analytics and BI, they go all hand in hand. They are all coming under one umbrella, and they all go hand in hand, because if you do analytics and you are not able to deliver it well to the end user or to the business users, then it is of no use, right? Whenever we talk about the big data, we cannot skip the 3 V's of the big data. Very, very important 3 V's. Now we speak about the 5 V's, but these are the basic 3 V's. I'll just give you a glimpse of the other 2 V's also, but to focus on the 3 V's of big data, right from the volume of your data to the velocity of the data and the variety of the data. In my past few slides, I've already given you a glimpse of the enormous amount of volume, velocity, and variety of data. But to be very specific, if you see in this figure, it is a very interesting figure wherein how we have graduated slowly from your ERP to the customer relationship management to web, and now to big data. So in terms of volume, right from megabytes to gigabytes, terabytes, petabytes. Now we are also talking about zettabytes, yottabytes, and maybe in future we'll be dealing with something called as bronchobytes. I will tell you in terms of bits what are these, the proposition of these bytes in terms of bits in the next few slides. But this is the volume of data which we are talking about now. Coming to the velocity of the data is nothing but the speed at which the data is coming. So earlier, if you see, it was almost as good as batch processing, then slowly it evolved, and now what we are talking about real-time streaming of the data, right? I already gave you the example of Google Maps with your car on the move. You can actually see the traffic conditions and I mean in real time, and take the best decision or the best route based on the traffic movements. So that is nothing but the velocity of the data and the variety of the data which we are talking about. Not only restricted to your transactional database, which was in a fixed format of typical rows and columns now, and earlier it was ERP, wherein we had the purchase detail, the purchase record, of a particular company. Then it evolved to CRM, where apart from that we did customer segmentation, then the customer touches, the support contacts. Then slowly it evolved to your web data, wherein you were able to maintain the web logs of the particular website, then the dynamic pricing, then the affiliate networks, search marketing, the behavioral targeting of every customer, and so on. And now finally we are talking about big data, wherein the data which we are dealing with, as I told you, is sensor data, then your RFID tags, then the devices, mobile data, user click stream. There is a field called a sentiment analysis, wherein based on the sentiments of the consumers, how big data is dealt with. Then it is user generated content. I already gave you the example how indirectly you are contributing to generating the data. Then you have your social media interactions, the social media feeds, the feedbacks which you are giving maybe on your Twitter, your Instagram, and so on. Apart from that, you have the video data, speech to text data, SMS, and so on. So, I mean, a huge amount of data, a very complex kind of data, and the ability to deal with this data is something which we should think of, right? So let me focus on the 3 V's of the big data. As I told you, I'll just give you a glimpse of, in terms of bits and bytes, what we are talking about. Now, you all know the size in terms of bit, that is, it is 1/8 of a particular byte. Okay, and if you look at this table, gradually we have talking about bit to byte, kilobyte, megabyte, gigabyte, then terabyte, petabyte. Now we are talking about exabytes, zettabytes, and yottabytes. Now, if you see, your yottabyte is nothing but 1 raised to power 24 zeros, that those number of bytes. Right now, what we are dealing with in current scenario is nothing but zettabytes or yottabytes in some case. But in future, very soon, maybe in another 2 or 3 years, we will be talking about something called as bronchobytes. Now, bronchobytes, it will be nothing but 1 raised to power 27 zeros. So, and of course, this is not going to stop here. The data is going to grow, grow, and grow. A slide which I'm sure, as I told you, many of you all at some point you all are using these social media sites. So just a glimpse of to tell you the amount of data which is being generated, the volume of data which is being generated every minute of the day. So Snapchat, yes, very common among students. So this Snapchat, it uses or shares almost 5,27,760 photos per minute. That is every 60 seconds of the day. Imagine the kind of data being generated. Then LinkedIn, more than 120 professionals, they join LinkedIn every minute. The users watch as good as 41,46,600 YouTube videos every day. Every minute of the day. Then almost 4,56,000 tweets are sent on Twitter every 60 seconds. Instagram, the Instagram users, they post almost 46,740 photos per 60 seconds of the day. So this is some very common platforms which all of us present here are using some point of the, at some point, I mean, in our day, mostly 3 or 4 apps out of these we use, right? So we can all relate to it and imagine the volume of data being generated every day using only the data which I have given you is only some of the social media sites or the day-to-day apps which we are dealing with. Apart from this, there are many other sources from which the data is being generated. Okay. Coming to the next V of the big data is nothing but variety of or the complexity of the big data. Now your data is not only related to the tables or transaction or legacy data, that is your transactional data, but now you're talking about textual data, NLP data, that is natural language processing, which is also one of the upcoming fields in data science or data analytics, like your Twitter handles. I mean, you post something on the social medium, right? So understanding that kind of data, understanding the sarcasm in that particular kind of data. Then you have semi-structured data or XML data. Then with this, you also have graph data or social network data. Now, whenever you use Facebook or Instagram, then in your contact list or some recommendations come that friends of friends, right? So what are they doing? They're basically trying to connect you or connect your network to other networks and try to establish linkages or relationships between your friends. And they are recommending that you can be friends with these particular people. So nothing but graphical data. Then you have your streaming data. Streaming data is nothing but the live data. GPS is one of the example. Then you have video surveillance data, the data which is captured from the video, the surveillance cameras. Even that is a streaming or continuous flow of data. Then if you talk about maybe analytics and finance, so people who do the trading in shares. So with every milliseconds or seconds, the price rates of the shares are changing, right? So that is nothing but continuous or live data or streaming data. So basically a single application, it can be generating or collecting many types of data, not only restricted to one single type. So, and as the variety or the complexity of the data increases, they come from the various sources. So is the way to deal with that particular data. It can be public data, That is nothing but online data, weather data, finance data, and so on. Okay, and to extract knowledge, all these types of data, they have to be linked together, because as I told you, for one particular company also, if you are working, the variety of the data for a single application will be different. So you need to establish linkages between all the sources and types of the data. Okay. Again, a single view to the particular customer and the variety of data which I'm talking about. Now, imagine you as a customer throughout your entire day, or I mean, a span of 1 day or 24 hours itself. Imagine the kind of data, the variety of data you are dealing with as a customer. To start with, as a customer, for your entertainment, you use Netflix, you use Amazon Prime, then you use Hulu, then NFL Network, and whatsoever. All these OTT platforms, right? Your gaming platforms, all these, the entertainment platforms, basically. So the kind of data which you are getting is video data, right? The recommendations which you are getting is video data. Then comes your gaming, online gaming, Xbox, PUBG, then earlier you had Counter-Strike, now Zynga. So all these are your online gaming sections wherein animated data which you are dealing with. But again, the data which you are dealing is streaming data. I mean, you actually have, whenever you're playing these online gaming platforms, you have a feel that you are one-to-one playing in a real life scenario, right? So the response time is so fast that it actually gives you a feel in a real-time environment. So that is nothing but your gaming data, your streaming data. Then comes you as a customer, you are using social media data, right? Be it Instagram, be it Pinterest, be it Facebook, be it WhatsApp, whatsoever, any social media data. The kind of data in this case can be images, it can be videos, it can be your simple textual or English language data, and whatsoever. Then comes your banking and finance data, a typically structured kind of data wherever you are doing your online transactions, maybe using cards, maybe using online banking and something like that. Then comes your known history data, that is if you are working in a particular company. So some structured data or secured data, maybe using SAP and for your IBM, Infosys, whatsoever. In whatever company you are using, the platform which you are using for that particular company base. And of course, your purchase or your shopping data, Amazon, Flipkart, Nonstadam, Lois, all these are the online data or the shopping carts which you are using to buy various products. So as a customer also, if you see throughout a span of 24 hours also, the variety of data which you are dealing with in 1 day. Right. Apart from this, of course, there are various other varieties of data, but I just wanted to give you a glimpse that indirectly how you are contributing or you're consuming various types of data throughout the day. The third V, very important nowadays specifically, is nothing but the velocity or the speed at which the data is coming. Because the speed at which the data is coming, the requirement to process that data in real time, if that is not done properly, then of course it is going to lead to missing opportunities. So data is being generated very fast and it needs to be processed also very fast. So that is why comes the upcoming field of online data analytics, because some late decisions are nothing but they are going to lead to your missing opportunities. Now, let me give you one example when I talk about speed of data and some missing opportunities. Now, healthcare monitoring. Healthcare is also one of the important fields where your data analytics is being used extensively now. So if you see that culture has not come in India as of yet, but in US, the culture is most of the senior citizens, they stay alone, right? So to monitor their healthcare, the sensors are placed in their house at various areas to monitor the activities of the senior citizens. If there is any abnormal activity, then immediately that is captured and it is processed and sent to the concerned officials, right? So any abnormal measurement requires immediate action. For example, the senior citizen, he has fallen, or maybe he's not keeping well. I mean, if there are any changes in his monitoring the readings, so immediately that is a transition, and that is taken care of, and it is processed in real time. Because if at all the processing is not done in real time, it may cause the life of that particular person, right? So this what I want to focus here basically is the speed at which the data has to be processed in real time is very important. Right. For example, there are video surveillance cameras in your ATM machine. I mean, wherever you use your ATM booths, the video surveillance cameras are there. If a theft is going on, and if that is processed in real time, that is captured and processed in real time, then it makes sense that we can take necessary actions and catch the thief and so on. But if it is not processed in real time, then later on you see the CCTV footage, you try to identify the faces and also whatsoever. But it is not going to have that particular impact if it is being processed in real time. So of course, the speed of data, specifically in some crucial areas, is very, very important. Now, talking about speed of data, again, some interesting figures. What happens in on internet in every 60 seconds, right? So the speed at which the data is coming, in Facebook, almost 7,01,389 Facebook logins are done every 60 seconds. Netflix, 69,444 hours of movies are watched every minute. Okay, WhatsApp, it is 2.8 million plus messages every 60 seconds, and many such interesting figures, which simply are telling you about the speed at which the data is coming every minute, and it has to be processed also in real time. So yes, the third V of big data. The remaining remaining two V's, because earlier there were three V's, now we talk about five V's. The fourth V is nothing but the veracity of the data. Now, by veracity of the data, I simply say it is nothing but the uncertainty of the data, or maybe the relevance of that particular data, or some missing values, or the authenticity of the data. That is the data which is coming. If it is not from a reliable source or a good source, as I told you, then the input will be wrong. If your input is only wrong, then all the other three V's go in vain, right? Like, for example, let me give you a very simple example of WhatsApp messages. Now, WhatsApp messages many times there are fake messages which are coming on, right? Now, based on one of such fake messages, if you start processing the fake message without checking the authenticity of the source from which that message is coming, and you start processing those kind of messages and try to develop some insight on that particular message, then of course your output is also not authentic and it is not right. Okay, so that is nothing but the veracity of the data. So if you see, almost 1 in 3 business leaders, they don't trust the information they make, to make decisions on particular data. That is the veracity of the data. And poor data quality, it has costed the US economy almost around 3.1 trillion a year because of the poor quality of the data. 27% of the respondents in one of the survey were unsure of how much of their data was inaccurate or accurate, right? So that is nothing but the veracity or uncertainty of the data. Of course, of the other three V's, I've already told you the volume or the scale of the data. Velocity is nothing but analysis of the streaming data, that speed at which the data is coming, and variety is the different form of through which the data is coming. Now, talking about the fifth V is nothing but the value of the data. Once the entire processing is done, what is the business value or the value addition you are doing to on that particular insight by taking some real life decisions or making some decisions which are going to impact the real life scenarios is nothing but the value of that data. So these are nothing but the 5 V's of the big data. Again, the data evolution, I would like to take you through this slide because again, it will make sense and you all will be able to relate because all of us have used these apps and are using rather these apps. So how the data has evolved over the years. So if you talk about in 1996 came the Google, of course it was existing earlier also, but now in 1996 came Google for public use as a search engine. And over the years, of course, it has progressed, it has evolved a lot. And do you know that today Google processes as much as over 3.5 billion searches per day. Now, if you calculate it, it is approximately 40,000 queries per second. That is the kind of processing speed Google is giving nowadays, 40,000 queries per second. Then in year 2004 came the most famous social media site, which is nothing but Facebook. And if you go by the statistics, we all know, so Facebook is a social media site. And today, if you see, India has the most number of active FB users. The number of active users in India in 2000 were 280 million, which have surpassed USA and Indonesia leading. That is, first is India, followed by USA, and followed by Indonesia. So most number of FB users are Indians. Then in 2010 came the very famous Instagram, right? We all use it. It is basically nothing but it's an American photo and video sharing social networking site, and which is also now owned by Facebook. And if you see, it is generating huge amount of revenues through its influencer market. I'm sure many of you all know who are influencers, and through influencer market, the Instagram is generating huge amount of revenues. Then in 2012 came the GPS enabled Uber, Ola, all these services. And today, if you see, looking at the figures all across the world, Uber alone, it makes almost 4 million trips per day. Oh, sorry, not 14 million trips per day. So imagine the kind of, and this I'm talking only about Uber. Of course, we have many other service providers in this area, but the Uber alone, it makes almost 14 million trips per day. Then evolved in 2015 something called as you have all heard about Alexa, right? Alexa. Then you have Siri. Then you have Amazon Echo, Google Assistant, right? What are these? These are nothing but these are advanced conversational analytic tools, which are highly powered by AI. And the kind of data which it is being used is nothing but audio data in this case, right? So that Amazon Echo and all these, they were publicly available, and they got famous in 2015. And in 2019, to be specific, came your most popular of all, which is TikTok. Unfortunately, it is banned now in India, but if it was still existing, it had showed promising results or promising future in 2019 itself when it was launched. You'll be astonished to learn that it was the world's second most downloaded non-gaming app in 2019 when it was launched. Now, by showing you this data evolution site, I just wanted to tell you how data has evolved and the variety of data and the speed and the volume of data which we are talking about. All the three V's I am trying to relate. That is the speed and the volume of data when I'm talking about Google search engine, almost 40,000 queries per second. To Facebook, that is the variety of data which we are dealing with. To Instagram, which is nothing but a video and a photo sharing site. To Uber, which is nothing but your streaming data or your live or your GPS data. To your AI-enabled data, which is nothing but your audio data and AI-monitored data, intellectual data, that is conversation analytics. And then comes your TikTok data, which is nothing but mostly your video data and your social media data. So this is nothing but the evolution of data over right from 1996 to 2019, and we are still dealing with this enormous amount of data. With every positives come some challenges also. So whatever data I've talked about, right, from the archives to your normal document data, to your business application data, media data, social network, public data storage, machine log data, or to your sensor data. These type of data are basically divided into structured data, semi-structured data, and unstructured data. We'll not delve deep into what are structured, what is semi-structured and unstructured data. But with this comes the complexity of the data also. So if you see in terms of complexity, right from the velocity of the data to the variety of the data and the volume of the data, this graph shows you the complexity level in terms of low, medium, and high for all the variety of the data which we are talking about, and the challenges in terms of the structured and unstructured data. This is nothing but I'll just give you some of the applications, a glimpse of some of the applications of big data analytics when we talk about. So it is being extensively used in healthcare, then fraud detection by the government also, some marketing, agriculture, trading analytics, and so on. So if you talk about healthcare or smarter healthcare, usually the healthcare industry, it has lagged when it comes to the use of big data, because of the most crucial reason is nothing but the resistance to the change, the providers being accustomed to making treatment decisions autonomously. Because again, when you talk about healthcare data, the analytics which has to be done should be of 100% precision. There is no scope for any error, because you are dealing with the human lives. But still, lot of research is going on in healthcare domain, maybe diabetes detection, heart rate detection, detection, then cancer detection at early stages, and there are possible remedies. Then, of course, comes the automation in healthcare, wherein now we are talking about doing operations remotely using robots, right? So again, your big data is playing a very important role here. Then comes something called as the area of security, which is nothing but fraud detection. So one of the most compelling examples of, I must say, for big data analytics is fraud detection, especially in the business, which involve any claims of transactions or processings. And now, in most of the cases, this fraud is discovered long after it's done. As I told you, ATM में आपका CCTV camera है, but आप बाद में उसका recording देखोगे और उसका video footage देखोगे, and then you try to catch the thief, so it will be very late. It means that the damage is already done, and then you are trying to find out, right? But analyzing the request and transactions in real time, detecting any anomaly or the behavior or a pattern in identifying your large scale of transactions through big data applications, it can definitely prove to be a game changer in fraud detection. Similarly, अगर आप banking transactions देख रहे हो, तो in transactions, if there are any certain abnormal kind of transactions, and catching those transactions in real time will of course give you very good results in detecting the frauds. Now, when it comes to government, if you know, the big data, it has always proved to be very useful for government sector also. It had played an essential role in not just the re-election campaign of Barack Obama, but in India itself, for the BJP and its allies to win the Indian elections in 2014, then again 2019. Various techniques were used by the Indian government, if you know, to find out how the Indian electorate is responding to the actions which are taken, and the ideas for policy growth to the government. What is the response of the campaigning which is going on, and what is the possibility for winning the elections, and so on. So it is also used by government. Marketing, if you see, this is a sector you cannot imagine the extent to which these business in marketing, they are using big data analytics. Now, very recently, I stumbled upon an article in Harvard Business Review. This study, on the basis of various factors which were published, it shows that the kind of advertisements that the compels the viewers to continue watching the ads, and the ones that dampens their interest level, because whenever you are watching some OTT platform, there's some ads come in between, right? So which ads you are watching and which are not seeking your attention. To perform the research, one of the tools that was used was nothing but a system to analyze the facial expression, which were revealing viewers' feelings. So similarly, other markets are also using this facial recognition software to know whether your advertisement is having an impact on the marketing or not. So the kind extent to which this data analytics is being used. Then, of course, it is being used in agriculture domain also, in using smart agriculture. The sensor data is being used to optimize the crop efficiency. It is used by biotechnological firms. Then this is used to measure how the plants will react to changes in various conditions by planting the test crops first and then running the simulations before doing the actual agriculture. Some simulations can be done so that there is not much damage to the crops. Its data environment continually collects and records the changes in the various attributes, like maybe the temperature, then the soil composition, then the water level, the growth, the gene sequencing of the crops, and output of each plant on the test bed. So which a combination is giving a better output, then that is recommended to the farmers to do this. And of course, it is also being done, used extensively in your trading analytics. That is, as I told you, who are dealing in shares or the online trading of the shares. So some high-end algorithms are being used, also called as algorithmic analytics in this algorithmic trading in this case. So they are being used to predict the futures of particular shares and companies and so on. So this is nothing but some of the research areas. Active research is going on in these particular areas of big data analytics. Before going, after this application of big data and analytics, there is a certain caution point also which I would like to mention here, apart from the uses. While big data, they have been a boon for any organization, but the threats surrounding these big data applications cannot be overlooked. Now, privacy has some big concern when it comes to the use of consumer data, especially the BFSI segment, that's the banking sector. Your big data analytics, they have potential to reveal the sensitive personal information by uncovering some hidden connections between pieces of data, which you as an end user would not like people to use that particular information. So as per the research, approximately, if you see now, 62% of the bankers, they still avoid using big data applications because of these privacy issues. But yes, there are many pros and cons, and of course that also gives us a scope of research area for security in that particular domain. So this is nothing but some of the top 10 analytic trends which are going to the future in this big data, right from augmented analytics to NLP or conversational analytics. Then you have continuous intelligence, explainable AI, graph analytics. Then you have something called as data fabric, augmented data management, commercial AI and ML, blockchain, of course, persistent memory servers, and so on. So there's a lot of scope and subfields in all of these areas where enough of research can be done. And this is nothing but overall the big data landscape, wherein the various players are there in the market in terms of technologies, the infrastructure, and the various applications at various levels. So this is just a glimpse of all the leading players in your big data analytics. So just to conclude, the bottom line I would like to say is, if optimized in the right direction, your big data is indeed a very powerful tool that will make things easier in various fields. We have already seen many of the scenarios of fields where your big data is playing a very important role. And apart from the above mentioned sectors, your big data application, it is also making very positive contribution in various fields of chemistry, data mining, cloud computing, finance, biotechnology. If you see the vaccine which is being made for COVID, so there is a large amount of data which is being involved for doing the gene sequencing, genome sequencing, and all those things, and to find the particular vaccine. Okay, so in such crucial applications, also your big data is playing a very important role. So with this, I end my webinar. If there are any questions, I would like to take some questions. Thank you.
Good afternoon, everyone. It gives me Aishwarya, coordinator of ZSCT department, immense pleasure to extend the vote of thanks for the very rich and information session conducted by Sheetal. Before that, let me take up some questions our participants have to ask our resource person. The participants, if you all have any doubts regarding the session, you all can put it in the chat box. Ma'am, there's one question from our student, that is Harsh. Is cloud-based solution a good option for big data?
Yes, it is a good option for big data, but as I told, depending upon the application which you are going to use, like still in banking domain, in financial related data, some sensitive amount of data, they are still not very much relying on cloud. Although they are talking about private cloud nowadays, and IBM, companies like IBM, they are coming with some very good on-prem solutions for cloud-based data also. But otherwise, for other applications, cloud-based data or cloud-based computing is a very good option for big data, because then in that case, you need not invest much on the processing power. Everything is available on cloud.
Okay. Ma'am, there is another question.
Yes.
Throughout the question, what I understand is that data here is very convolved. How much is AI involved in this nowadays when curating these data from different sources?
As I told you, now this business intelligence, AI, data analytics, you cannot separate them from one another. They all go hand in hand, because see, if you specifically talk only about AI or artificial intelligence, you need to train your machines, right? But for training your machine, you require test data. The more the amount of data, the better your training, the better the results, the more accurate the results. So you cannot really segregate between artificial intelligence and big data. They will definitely go hand in hand. Unless and until you have big amount of data, you cannot perform good AI techniques on those kind of data.
Okay, thank you, ma'am. Any other questions participants have? Okay. Now, thank you so much, ma'am, for answering all the questions. Okay, there's one more question.
Yeah, the question was, what is infrastructure as a service, right? If I'm not wrong.
Yes, ma'am.
Okay, so infrastructure as a service is nothing but the cloud-based platforms which we are talking about, right? Infrastructure as a service, wherein you don't have to set up the entire infrastructure. They are readily available on the cloud, and you can simply use their services by paying only as much infrastructure as you are using, because you as an end user or as a small company, it is not advisable to make a huge amount of investments on the infrastructure itself, right? So what these cloud-based platforms are doing is they are offering you the infrastructure pay per cost. I mean, the amount which you are using, you are paying only that much amount for the infrastructure which you are using. So yes, this is a technique which AWS or all the other cloud platforms, they are offering infrastructure as a service for the end users. Which tool is better, Hadoop or Apache Spark? Again, if you see, depending upon your application, and you cannot segregate ki Hadoop is being used or Apache Spark is being used, because Hadoop is basically a file structure, right? HDFS is a file structure wherein you process your data, you have your map reduce, wherein automatically your data is segregated and it is being processed. Spark is nothing but a tool which is going to be used to process that particular data on the Hadoop platform. Hadoop also, it can be, if you see, to perform some operations on Hadoop, it may be on cloud era. That is, you can use the cloud capability also for Hadoop, as well as you can install it on your own desktop also. So again, there are two options for Hadoop, processing Hadoop as well. But Spark is, Apache Spark is nothing but a tool which is being used along with your Hadoop.
Thank you, ma'am. Are there any other questions? Okay. I suppose there are no questions because the session itself was very clear. I would like to thank Dr. Sheetal Rathi Madam for sparing time from her busy schedule and giving us an insight into aspects of big data which can help our students to get knowledge about this interesting domain, making projects based on the topic and carrying it forward in their future endeavors. I also thank Dr. Mili Jishank Ma'am, in charge principal of ZSCTs Thakur College of Science, for giving us an opportunity to organize such a webinar for the development of students. I extend my sincere thanks to the members of the management, coordinators, faculty, and staff of Thakur College of Science, the students, participants within and outside of the institute for attending the webinar and making it a success. Last but not the least, I also thank Ms. Pragya Sawant, coordinator of BSc Computer Science, for her constant support in organizing the webinar. I would like to inform all participants to kindly fill the feedback form posted in the chat box so that the certificates can be mailed on their respective email IDs. As the webinar is live on YouTube, please do like, share and subscribe to our channel for such more interesting webinars. Thank you once again. Stay safe, everybody. Thank you, Sheetal ma'am. All participants, please fill out the feedback form so that we can mail you the certificates. Certificates will be mailed to you, Mr. Manan Mehta. It will be mailed to you. Okay, just a minute. You can check the feedback form now. Kindly fill the feedback form. Dr. Amit Kumar, we'll get back to you. We'll speak to the resource person that we have today and we'll put the presentation, if given permission by her, on the Telegram group. Thank you, everybody.